Hello everyone. In this video, we will be discussing some numericals based on future worth analysis and payback comparisons. Already in video 4, we had some numerical discussions. I request you to go through that particular video, then it will be easy for you to understand these numericals because it is comparatively little tough. So we will see how to solve the problems. And as we know that here we will be discussing even the payback analysis, the capitalized cost analysis. For this formulas, we are using here is a into 1 minus 1 divided by 1 plus I power n divided by I. As the number of years is approaches to infinity, because the number of years, the servicing years will be unpredicted. Sometimes it can be 100 years, 200 years. So the bracketed terms becomes 1 by I. So the symbol CC replaces PW and annual worth replaces A2 yield. So CC will be equal to AW divided by I. And this is the important formula we need to remember whenever we solve. And already we had discussed these two problems, that is this problem and this problem, where for the different cases also we have discussed along with the cash flow diagram. So now we shall discuss this particular problem. The Havarti Country Transportation Authority, so in short form HCTA, has just installed new software to charge and track toll fees. The director wants to know the total equivalent cost of all future costs incurred to purchase a software system. If the new system will be used for the indefinite future, find the equivalent cost. Number one, now a capital cost value, and for the B, for each year hereafter an annual worth value. The system has an installed cost of $1,50,000 and an additional cost of $50,000 after 10 years. That is a salvage value. The annual software maintenance contract cost is $5,000 for the first 4 years and $8,000 thereafter. In addition, there is expected to be a recurring major upgrade cost of $15,000 every year for 13 years. Assume that I equal to 5% per year for county funds. So this is one of the problems where we need to pay our attention more, because there are a lot of tricky information is given in the problem. So the important informations which may confuse us is nothing but this annual cost maintenance, where for the first 4 years it is 5,000 they mention, and for remaining 7 years it is 8,000. So we should be very careful when we do these kind of problems. And the percentage of interest, and for the county funds it is 5% per year they have mentioned, not for all 13 years. So we'll see just how to solve this particular problem. So the 5-step procedure to find the capital cost now is applied. First, number one step, we need to draw a cash flow diagram for the two cycles. So in this sketch we can able to see the cash flow diagram for the two cycles. First, what is the first case they have given, where the installed cost is $1,50,000. Since it is an investment, in the cash flow diagram we are supposed to show it in the downward direction. We can able to see that. And second thing is, for the first 4 years the annual maintenance of 5,000, you can able to see 1 2 3 4 for the first 4 years. Since it is again an investment from owner side, he need to pay money from his hand, so again it is downwards. So $5,000. And for the rest of the years, the remaining 7 years, it is 8,000. 1 2 3 4 5 6 7. You can able to see this for the remaining years. For the 10 years, because first cycle is for the 10 years, so 4 means 1 2 3 4 5 6, only for the 6. So it is 8,000, and the interest rate is 5% per year. And you can able to see how I'm differentiating the maintenance cost for the first 4 years and remaining 6 years is with the size of the arrow marks. The first maintenance cost arrow mark is smaller compared to the 8,000. And moving to the continuation of the same condition, where it has suddenly increased of the investment of $50,000 dollar. That is an additional cost after 10 years. You can able to see, because maybe for increasing of some accessories or adding up some more features which will make it very effective. So considering that one, the $50,000 is additionally invested at the 10th year, and from the 10th year to the next 13 years, you can able to see next 13 years, the every year of install what is that the for every 13 year, $15,000 is the um, for the again for the upgrading purpose, they have to invest. So you can able to see the for the first 13 year 15,000 they have invested, and from the next 13th year 26. So you can able to see this 1,50,000 initially he has deposited, looking at the total future age like servicing year of 26 years. So this is the total number of years. After drawing the cash flow diagram only, we can understand what is the total number of years of service. So this is the cash flow diagram, and if it is not compulsory all the years we need to show, even by using these kind of cut marks we can able to mention that okay it is 14 to 20 or 20 to 26. The number of years we need not to show like 1 to 26 years, but wherever it is necessary we need to show the difference. And the second thing is we need to find the present worth of the non-recurring cost of 1,50,000 now, and 50,000 in the year of 10th year, 5% interest. So let me substitute like $1,50,000 as I invested, and $50,000 at the 10th year also I have invested of interest rate of 5 years. So I'll be getting $1,80,695. And next we need to convert this $15,000 recurring cost to a value over the first cycle of 13 years, and we need to find the capitalized cost, that is CC2, at 5% per year using the first equation. So the A will becomes minus 15,000 of 13% interest, so I'll be getting it is minus 847. So I'll be substituting this A value in the CC2. So minus 847 divided by interest of 5% is 0.05. So I'll be getting minus $16,940. So there are several ways to convert the annual software maintenance cost Cs to A and CC values. A straightforward method is to first consider the $5,000 and ACs within capital cost of. So CC3 becomes minus 5,000 divided by 0.05, that is 5% interest. So I'll be getting $1,00,000, that is the negative sign. And the second, convert the step of maintenance cost CDs of $3,000 to a capitalized cost, that is CC4 in year 4, and find the present worth in year 0. So again for the cash flow diagram reference, I'll be taking this one. So CC4 will be equal to minus 3,000 divided by 5% interest. So I'll be getting minus $49,362. And the next step, the total capitalized cost CCT for Haverty County Transportation Authority is the sum of the four component CC values. So I'll be adding up all these things because it's the different values I got. So minus 1,80,695 plus minus 16,940 plus minus 1 lakh plus minus $49,362. So altogether I'll be getting the total capitalized cost for all these years is $3,46,997. So this equation determines the A annual worth value forever. So I'll be doing it for interest considering. So I will be getting the interest of approximately $17,350. So correctly interpreted, this means Haverty County officials have committed the equivalent of $17,350 forever to operate and maintain the toll management software. So this is how this problem has to be solved. So the formulas have to be remembered very well, particularly this formula and even the present words formula, whatever we have used, including the future words. So with this, I'll be winding up this video. Any doubts? Please clarify your doubts in the next class. Thank you.